This video shows how to use the FSP configuration settings for RZT and RZN devices. It will also give examples so that you can understand and follow. The process of FSP configuration in both eSquare Studio and FSP Smart Configurator is similar, hence this video tutorial will show the process using eSquare Studio. Here are the acronyms used in this video. This video is the second tutorial for FSP configuration. In the first video, we introduced you to the tabs available in FSP configuration. In this video, we show you how to use them. Among these, there are frequently used tabs such as the BSP, clocks, pins, stacks, interrupts, and event links tabs. Pins tab was already introduced in another video. Please see the link provided in the video summary section. We begin with the BSP tab. This is the instruction for modifying individual items for those who want to change from the setting at the time of project creation. Move on the BSP tab and click on the FSP version item to select the flexible software package version installed in eSquare Studio. Up to now, you can install and use version 2.0 of the RZT device. There are various types of boards and boot modes that you can select by clicking on the board item. For instance, we select the Renesas Starter Kit board for RZT2M device, which operates in RAM execution mode without using flash memory. For your own board, you have to select the RZT or RZN custom user board with the appropriate boot selection scheme and need to insert all other configuration items mentioned in this video. In the device item, you can select the target device and package. You can either use the auto set option when selecting the board or follow specific steps to make changes. Click on the device rectangle area. The device selection screen will pop up. This screen shows the RZT series devices and their pin packages. Here we use the default option of this project as an example. Next, we have the core item. The RZT2M device utilizes the Cortex R52 with CPU 0 and CPU 1. Currently, FSP version 2.0 supports both CPUs. For example, we select CR520 option. The last item is RTOS. Currently, it is displaying only no RTOS and that cannot be changed. The reason for this is that when the project was created, no RTOS was selected. If you choose an RTOS version, free RTOS, that section will display free RTOS. The additional setting options of this tab can be set up in the Properties view. In case the window is not visible, you can find it under the Show View section in the window menu. Within the BSP properties, you can enable or disable parameters, memory configuration, multiplex interrupts, etc. While there are many configurable properties, a solid understanding of ARM knowledge is necessary before adjusting these properties. In this video, we use the default BSP settings. After clicking the Generate Project Content button, you can see the contents in the BSP folder. For more details, follow the path displayed in the blue box to check the generated contents. In the Clocks tab, we introduce you how to set up clock source and check the current clock settings. In the clock tree visualization, gray-colored blocks indicate adjustable clock settings, allowing you to modify clock values or states. Conversely, white-colored blocks represent fixed default values. To change the clock source, simply click on the clock where you want to make the change and select the desired option from the drop-down menu. You can view clock descriptions by pointing into the block and waiting for 1 to 2 seconds for the description to appear. After selecting, you can click on the Generate Project Content button. You can check the clock-related generated content by following the path displayed in the blue box. This section will guide you on how to add a new driver in the Stacks tab. You can add drivers in the Stacks tab by clicking on New Stack. It shows a drop-down list of HAL-level drivers available in the FSP, and you can select from among them. When you click on certain drivers, such as our MTU3, the Extend Stack button will light up to indicate that the driver supports extending the stack. To extend the stack, you click on the Extend Stack button and then select the driver to extend from the drop-down list. Additionally, the FSP Smart Configurator supports you in finding and adding drivers through the Search feature in the Stacks tab. To add a driver using the Search feature, you click on the New Stack button, then select Search from the drop-down list. The New Stack dialog box will open. In the New Stack dialog box, type the name of the stack you want in the Type Filter text field. The related drivers will be listed. Select the driver and click the New button to add it. Perform similar steps to extend the stack using the Search feature. This section guides you on how to use the Stacks tab through examples. The examples include adding drivers and handling errors during the driver addition process. The first example describes adding a driver that does not support extending the stack and encounters no errors. We will use the RCGC stack as an example in this case. You can choose one of the two methods for adding drivers as introduced in the previous section. This example will use the direct addition method by clicking on New Stacks, selecting System and choosing Clock Generation Circuit, RCGC. The settings and properties are kept default, then click on the Generate Project Content button. After clicking on the Generate Project Content button, the RCGC stack property will be automatically generated. You can check the generated contents of this stack in the header and source files by following the path indicated in the blue box. The second example describes adding a driver that supports extending the stack and provides guidance on how to handle errors encountered during the driver addition process. We use the RGPT stack as an example in this case. You add the RGPT driver by clicking on New Stack, selecting Timers, General PWM, RGPT. To extend the stack for the RGPT, you select the RGPT stack, then click the Extend Stack button. In the drop-down list, select Timers, and select 3-phase PWM to extend the RGPT stack with the RGPT 3-phase stack. Return to the added RGPT stack. Then, select the driver module in the HAL Common Stacks section and configure the driver properties in the Properties view. In this example, we select the General, Interrupts, and ELC properties for configuration. For more details on the settings, please refer to the information in the blue box. In the General, we change some properties, such as the channel of the GPT module, the operation mode, and the period timers. In the Interrupts option, we modify the priority of the overflow interrupt. When enabling interrupts in the Stacks tab, they will also be automatically added to the Interrupts tab. Further explanation can be found in the Interrupts example section. In the ELC, we select the trigger source of the GPT driver. After configuring this setting, an error appears in the Stacks tab. To resolve the error, hover your mouse over the RGPT stack. A pop-up message will appear. Please follow the instructions in the pop-up and adjust the settings accordingly. In this case, the pop-up message requires an ELC driver to resolve the error. Following the guide from the pop-up message, you need to add the RELC driver by clicking on New Stack, selecting System, and choosing Event Link Controller, RELC. After adding the RELC driver, the error disappears. Then click on the Generate Project Content button to generate the source code automatically. The RGPT stack property will be automatically generated. You can check the generated contents of these settings in the header and source files by following the path indicated in the blue box. This section will guide you how to use and add new interrupt events in the Interrupts tab through examples. The first example illustrates the process of adding new peripheral interrupts. To add peripheral interrupts, simply click on the New User Event button. We use the RGPT driver as an example, so in the drop-down list, select GPT, then Unit 0, followed by CH0, and finally GPT CCMPA. Next, the New User Event dialog box opens. You enter the name of the ISR for the new user event and click OK to complete. Information about peripheral interrupts will be displayed in User Event and Allocation section. To generate source code automatically, you click on the Generate Project Content button. The interrupt content is automatically generated in the vector data header and source code files. To locate it, please follow the path displayed in the blue box. You can delete a peripheral interrupt that you have created by selecting the peripheral interrupt in User Events and then clicking on Remove. If you click the Generate Project Content button again, the interrupt content will be cleared in the header and source files. The second example describes how you can use the Properties view in the Stacks tab to enable interrupts by setting the interrupt priority. To add peripheral interrupts for the RGPT driver from the Stacks tab, you select the RGPT stack in the HAL Common Stacks section and configure the driver properties in the Properties view. In the Interrupts property, change Overflow Crest interrupt priority from Disabled to Priority 0. Next, you switch to the Interrupts tab to check if the peripheral interrupt has been automatically added in the Allocation section. Click on the Generate Project Content button to automatically generate the source code. You can check the interrupt generated contents and the definition of interrupt service routine by following the path indicated in the blue box. To remove peripheral interrupts from the Stacks tab, first reset the priority of the overflow interrupt to Disabled. Next, click the Generate Project Content button. This action will clear the interrupt content from both the source code and the header files within vector data. The final part guides you on how to use the Event Links tab through an example. To add a new event in the User Events Produced section, simply follow the instructions outlined in the blue box. After setting the event in User Events Produced, you need to register a new event in the User Events Consumed section. The event destinations are defined by clicking the New User Event button. In the New User Event dialog, select LLPP-GPT event in the Peripheral Function field. In the Event field, select GPT-ADTRGA and click OK to complete. Once a consumer is linked to a producer, the link will appear in the Allocations section at the bottom. However, the Event Links tab shows an error. To resolve this error, you need to move the mouse to the consumer, and a pop-up message will appear. Follow the pop-up instructions and change the settings to resolve the error. In this case, we need to add the ELC driver, so change the tab to the Stacks. You add the RELC driver by clicking on the Stacks tab, then clicking on New Stack, choosing System, and clicking on Event Link Controller, RELC. After adding the RELC driver in the Stacks tab, you navigate to the Event Links tab, where the previous error has been resolved. To delete user events consumed or user events produced, you simply need to select the object you want to remove and then click the Remove button.